Hey guys, it's Mr. Bicen, and we're going to be doing every exam question that's ever been asked, this time on averages and spread from the probability and statistics section. Now, there are kind of three sort of topics here, but we're going to do all of them in one video. We're doing averages from tables and charts, the reverse mean, and then just one question on comparing distributions. So we're going to begin with the estimated mean from a table here, and it says this table shows the information about the weekly earnings of 20 people who work in a shop. Work out an estimate for the mean of the weekly earnings. Now, it's a non-calculator one, but that's fine because the midpoints of these things that we have here are all pretty nice. So I'm going to begin by just saying the midpoint of this first group is going to be 200. The midpoint of this group is 300. The midpoint here is 400, then 500, and then 600. Now, to find the average, the mean from a table, we're saying we've got 1 who we think is going to be 200, 11 earning 300, 5 earning 400, etc. So actually just multiply these values together to work out the total earnings of the 20 people who work in the shop. So 1 times 200 is 200. 300 times 11, well, 3 times 11 is 33, and I'll add on the 2 zeros. 5 times 400, 5 times 4, add on the 2 zeros. That's going to be a 0, and then 6 times 3 is 18, and add on the 2 zeros. So if I want to add these together, I probably would just add them like a few at a time. So these are 3,500, and then I'm going to add on a 2,000 and a 1,800. Well, that's a 3,800. So when I add these together, 8 and 5 is 13, 3 and 3 is 6, add on the 1 is 7. So it is going to be 7,300, and we divide it by how many people there are, which is the total of the frequency. So I'm going to be dividing it by 20. Sometimes people think you divide it by 5, but it's because there's 20 people. So obviously 700, if I'm doing 7,300 divided by 20, that's the same thing as just doing 730 divided by 2, because obviously I can cancel these zeros like this. So I'm just going to see 2 goes into 730, it goes into 7, 3 times remainder 1, 6 times into 13 will remainder 1, and then 5. So it looks like our answer is going to be 365, and because it's wanting it for the estimated weekly earnings, I'm going to put the pound sign at the beginning, but I don't think they would mind if they didn't. Nadia says that the mean may not be the best average to represent this information. Do you agree with Nadia? And you must justify your answer. Well, the reason this might not be a good idea is because we've got these 3 people here who are outliers. They're quite far away from the rest of the group. If you think to yourself who these 3 people might be, maybe they're like the supervisors or the managers who get paid more, and it would be more meaningful to do something like the median instead, because the median isn't affected by outliers. So I'm going to say, do we agree with Nadia? I'm going to say yes. I'm going to say there are outliers here which will have affected the mean. There are outliers here which will affect the mean. So maybe a median would be better. Let's see what we've got as the answers. We've got 365 and some kind of comment about the outliers affecting the mean, which we've got there. Okay, we're going to do another estimated mean from a table, and this time we're allowed to use a calculator. So I'm going to do the midpoints in between 5 and 10 is 7.5. We're then going to have a 12.5, 17.5, and 22.5. I'm just going to multiply all these things together, and then I shall add them up. So 7.5 times 1 is obviously just going to be 7.5, so I'm just going to write that one in as 7.5. Now 12.5 times 2, that is just going to be 25, but the rest I'm going to use the calculator for. So I'm going to do 17.5 times 7, so that's 122.5, and then I'll do 22.5 times by 8. And that is 180. So I'm going to total these. So on my calculator, I'm going to do my 180. I don't know why my calculator always does this. I should start at the top. I'll do 7.5, 25, 122.5, and 180. So they add up to 335. Now, if I add up these frequencies, I know it's going to be 18 because of the fact that there's 18 of them. So I'm actually just going to still write that in, that is 18. And I shall do 335 divided by 18. So the mean is 335 divided by 18. So I've already got my answer, so I'll just do the answer divided by 18. It is 18.6111, and it wants it to 3 significant figures. So I'm just going to say that it is 18.6, and the time is in seconds. You don't need to write the seconds, but we're looking for the answer 18.6, which we have here. Okay, so now let's have a look at this one. It says, the category of the question, which you can always tell in this top part, it's an estimated mean from a bar chart. Fran asks each of her 40 students how many books they bought last year. The chart below shows information about the number of books bought by each of the 40 students. So I'm just going to quickly jot these numbers down as their frequencies. So this first bar has got 11 as the frequency, then 8, then 13, then we have 6, and then our last one is 2. And the question says, work out the percentage of these students who bought 20 or more books. Well, 20 or more are these 2 students. So it's 2 out of the total of these numbers that we've got here. So I'm just going to quickly work out those totals. So that's 11 plus 8 plus 13 plus 6 plus 2. So it is 2 out of 40. And then to turn it into a percentage, I'm just going to multiply it by 100. So I'm going to do 2 out of 40 multiplied by 100, and we get that the answer is 5%. So for this part we have here, it is 5%. Now part B, it says show that an estimate for the mean number of books bought is 9.5. So I'm going to try and do like a table here. I'm going to do my midpoint, and then I'm going to do the frequency, and then I'm just going to kind of do the same pattern as what we would do usually. So the midpoint for this first category is 2, then it's going to be 7, then it's going to be 12, then it's going to be 17, and then it's going to be 22. So we have 2, 7, 12, 17, and 22, and the frequencies are 11, 8, 13, 6, and 2. So when I multiply these things together, we're going to total those, and we're going to divide it by the total of the frequency, which I know is 40, because it's actually in the question. So there was me adding those things up. You should have been telling me, well, it's already in the question. So when I multiply these, that's a 22, that's a 56. I am going to be lazy for 2 of them just to make sure that I don't make a mistake. So I'll do 12 times 13 and 17 times 6. 12 times 13, that's 156. And then my other one was 17 times 6, so 156 and 102. 156, 102. And now I'm going to total up all of those values that I've got along there. So that is let's clear this, it's a 22, a 56, 156, 102, and 44. So we get 380. So my last part is just to write down that the mean is going to be found by doing 380 divided by 40. I know what the answer is going to be because they've already told me, so I'm doing my answer divided by 40, and it is 9.5, which was already given to us in the question. So we'll double check we've got the first part right, which was our 5%, and we've shown that it was 9.5 with our working out that we did. So we're no longer doing the mean anymore, we're looking at the median from the table. This table shows us some information about the dress sizes of 25 women. And we're going to try and find the median dress size. So what you need to do is you kind of need to imagine that this data is kind of out in a long list. So it says that there are 2 8s, which means there's an 8 and an 8. There are 9 10s, so there's 1, 2, 3, etc., etc. Now the median would be the one that is in the middle position, and because there's 25 women, we're going to say that the middle position, I don't know if you've seen this before, you add 1 to it and you divide it by 2, so that's 26 divided by 2, it's the 13th position. So we just need to find out which dress is in the 13th position. Well, there are 2 that are dress size 8, then there are 9, so this represents 11 people. So the 12th and 13th people, the 13th person is going to have a dress size of 12. So the median dress size is 12. And then it says 3 of the 25 women have a shoe size of 7. Zoe says that if you chose at random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 9 over 25, because she's saying this is the shoe size of 7 and this is the dress size of 14 because there's 6 out of 25 and it's 9 out of 25. Is Zoe correct? You must give a reason. Well, it's kind of weird. We don't actually know if Zoe is correct, but the reason that she might not be correct is because we don't know if these people with shoe size of 7, they might also be someone who has a dress size of 14, in which case we've over-calculated it. So we're going to say, is Zoe correct? We can say possibly not. Possibly not. Someone with shoe size 7 may also be dress size 14. May also be size 14 dress. Bit of a weird question. They haven't asked something like that for a long time. This is in, like, I think the original paper that was done. I've never seen them ask anything similar. So we have 12 and then a statement about not being mutually exclusive. So for example, a person could be in both categories. So possibly not, someone with shoe size 7 may also be size 14 dress. We're going to do another median for a table, and then we're going to do a frequency polygon, which is going to come up in some of the other videos later. So if we're going to try and find the median this time, there are 80 children. Now, because it's grouped, you still could do the 80 plus 1 divided by 2, which is the 40.5th. Or, because it's grouped, you can just do 80 divided by 2 and just find the 40th position. Either of these are fine, and actually when you get to A level, this is the one that you would do. So if we're looking for the 40th position, sometimes the cumulative frequency might help. Cumulative frequency means how many people are up to that group. So there's 4 and 11, that would take me up to 15. And if I add on 24, that takes me up to 39. So let's just quickly remind ourselves what that means. Out of these 80 children, 39 are between 130 and 160. And because we're looking for the 40th, or the 40.5th one, that means that that child will definitely be in this group, because the first 39 children are in these groups. So the 40th children is going to be in this class interval. So the answer is 160 to 170. Now I'm going to do the more frequency polygons in a separate video, but we're going to draw the frequency polygon for this one. All you need to do is make sure that you plot the midpoints of the group with the frequencies. So I'm going to just label, these are my little midpoints that I'm going to use for those groups that we have at the top, and we're going to do the frequencies. So we have a 4 for the first frequency, then we have 11, then we have 24, then we have 22, and then last of all we have 19. And when you connect these together, you just connect them using a straight line like this. Don't connect the first one to the last one. Oh, that didn't do a ruler for me. There we go. And that is it for a frequency polygon, a very easy 2 marks to get. So we've got the 160 to 70, and then this is the same stuff we've just said about the frequency polygon. Now we move on to the questions that are the reverse mean. Remember, when you use this document, there's always a clue about the subtopic as well. I say it's the reverse mean because when we read the question, we will see they've already told us the mean marks, and we're going to try and go backwards to find out something else. So it says there are 10 boys and 20 girls in a class. The class has a test. The mean mark for all the class is 60. The mean mark for the girls is 54. Work out the mean mark for the boys. Okay, well, what we're going to want to do, if we're going to try and find the mean of the boys, we want to know the total of the boys, and we want to divide it by how many boys there are, which is 10. Now, we don't have enough information then, but we do know that the mean of the whole class is 60. So 60 is equal to the total of the class divided by how many there are in the class. And if there's 10 and 20 in total, there are 30. So that's probably going to be useful in a second. We also know that the mean for the girls is 54. So that's going to be the total of the girls divided by how many girls there are, which is 20. So I'm going to start off by solving this first equation. I'm going to do 60 multiplied by 30. It's a non-calculator paper, but that's fine. So if I do 60 times 30, 6 times 3 is 18, add on the 2 zeros. That is the total number of marks for the class. Now I'm going to do the same thing for the girls. So I'm going to do 54 times 20. 54 times 20 is going to be the total of the girls. And 54 times 2 is 108, and I'll add on the extra 0. So that is the total mark for the girls. So I'm going to try and use this thing that I've got here. I might put it down here. If I want to find out the total mark of the boys, I'm going to do the total of the class minus the total of the girls, because that should be how many marks the boys got. So that's 1,800 minus 1,080. And whatever method you want to do for that, you end up with the answer 720. So the mean of the boys is going to be the total of the boys, which is 720, divided by 10, which is 72. So the mean mark for the boys is 72. Yep, there's the right answer, and you can see the working that we've got here for the total of the class, the total of the girls, subtracting them, and then dividing by 10. Okay, I just don't have anything else we need to say. No, that's all good. This time we've got something really similar, and it's also from a non-calculator paper. It says that 4 red bricks have a mean weight of 5, 5 blue bricks have a mean weight of 9, one green brick has a weight of 6. Donna says the mean weight of the 10 bricks is less than 7. So you can't just find the mean of these 3 numbers because there are different quantities of each one. So I'm going to begin by finding out what the red bricks weigh. Well, there are 4 of them, and on average they weigh 5 each. So that's going to be 20 kilograms for red. For blue, there are 5 bricks, and each of them on average weighs 9 kilograms, so that's 45 kilograms. And then for the green one, there's just 1 brick, and it weighs 6 kilograms, so that is just 6 kilograms. So if I want to find out the mean, I will get their total weight, which is 20 plus 45 plus 6, and I'm going to divide it by how many there are. And there are 4, 5, and 1. That is 4, 5, and 1 bricks. So 20 plus 45 plus 6, well, that's going to be 65 plus 6. 65 plus 6, yeah, that's going to be 71. And 4 plus 5 plus 1 is 10. So the mean is actually 7.1 kilograms. So is Donna correct? Nope. Donna is incorrect, because 7.1 is obviously more than 7. So she's incorrect, no, and it is 7.1, and we've definitely got that one correct. Okay, we've got a calculator one, so I'm going to put my calculator back over here because I'm probably going to use that in a second. It says there is a total of 45 boys and girls in a choir. The mean age of the boys is 16.2 and the mean age of the girls is 16.7. Calculate the mean age of all of them. So the mean is going to be the total divided by how many, the total of all the ages divided by how many there are. So I'm going to start off with the boys that we've got over here. So for the boys, we know that the mean is 16.2. So we're going to try and find the total of the boys, because the total divided by how many there are is 16.2. So the total of the boys is going to be 16.2 times 18. That's their total ages. And 16.2 times 18 is 291.6. I'm going to do now the same thing for the girls. So it's going to be the total divided by how many there are is 16.7. So the total of the girls are those two multiplied. You can see why it's called the reverse mean, because we're actually doing a multiplication rather than a division. That's why I've called it the reverse mean. So we do 16.7 times 27. That is 450.9. So our final calculation that we're going to do over here, the mean is going to be our 291.6. That's the total of the boys. We'll do the total of the girls, because that's the total of everyone, and we'll divide it by 45. So I'm going to do 291.6 plus 450.9 divided by 45, and we get that the mean age, is 16.5 years. Now the mistake that people sometimes make on this is that they just do, oh, we'll just do the mean of these two things, but you have to correctly scale it to account for the fact there are more girls than there are boys. So we've got our 16.5 there. Okay, this is the last question in this video, and it's comparing distributions, and there's a set thing you have to do for these kind of things, and I'll get to that when we get to that question. It says the table shows information about the heights in centimetres of a group of Year 9 girls. So we've got the least, the median and the greatest. This stem and leaf diagram shows information about the heights in centimetres of a group of 15 Year 9 boys. And they've told us the key, and we've got the stem and leaf diagram. Compare the distribution of the heights of the girls with the distribution of the heights of the boys. So if they ever ask you to do this kind of compare thing, you need to compare two things. You either need to compare the mean or the median for your first one, and for your second one, you either need to compare the range or the interquartile range. Either of these things would be accepted. So in this case, because I've got the median, I'm going to be doing the median, and because I've got the least height and the greatest height, I'm going to be doing the range. So I'm going to start off with a comparison of the median by finding the median for the boys. So the median of the boys, okay, well, there are 15 boys here. So I can just do the crossing off from either end, or I could say that it's going to be the 8th position. But if I cross off 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and I'll just be careful here, I'll cross this one and this one. So the median is 8, which is in the 8th position in order. So the median isn't actually 8, it's going to be 168. So the median of the boys is 168 centimetres. I'm also going to find the range of the boys. The range of the boys was going to be the biggest take away the smallest. That's 182, and I think that's 158. So I'm going to do 182 minus 158, which is going to be 24. We're also going to figure out the range of the girls up here. So the range is simply going to be 170 take away 150, which is 20. So when we compare the distributions, we're going to say that the median of the girls' height is smaller than the median of the boys. So the median girls' height is smaller than the boys, as 165 is less than 168. The range of the girls' heights, what is it, 20 versus 24, is smaller than the boys. Is smaller than the boys, as 20 is smaller than 24. Now they do want one of them linked to the context, which is why I've said that the girls' height, really this median is saying that the girls are shorter and they have less range in their answers. So it is the 20 and 24. We need to have the correct numbers. So we did get the correct range for the girls and the correct range for the boys. And they want something like this. The median height for the girls is less than the median height for the boys, and the range for the girls is less than the range for the boys, which is exactly what we had. So that's all of the questions that have been asked on averages and spread. But you do obviously need you need to understand averages and spread to be able to help you answer other kinds of questions. So in the next video, I'm going to be continuing, and we're going to be having a look at some frequency charts.